Morning to you, Jaydeep.
Morning, good evening.
Very good morning to you, Jaydeep. Jaydeep, am I audible?
Yes,
Are you able to see me?
no.
Okay.
Your,
We,
your
we, we
we
just set, we're just setting things up. We should be up in about a couple of minutes.
okay.
Thank you so much, Jaydeep, for joining. Thank you for joining. We are all set. We should be able to start in the next 10 minutes.
Okay, no problem.
Good evening to you, Mr. Shaju Bhaskaran, sir. Mr. Shaju Bhaskaran, sir. And very good evening to you, Professor Venkateshwaran, sir. Jaydeep, hope my face is visible now.
Yes,
Thank you. Thank you, Jaydeep. Thank you so much. I understand you've been having a lot of visitors last few days. Thank you for giving us this kind of time. I understand this is morning 8:30 for you in Florida.
yeah, it's okay. It's fine.
We have registrations across India, a good number of registrations from the DAV Institute of Management
are required for you to step into the world of space science and technology. So I would request all the students to perform at your best so that you can enter into such fields and excel in your life. So with this, I would conclude and would like to listen to Dr. Jaydeep learn more about moon, its origin, and how what other explorations are taking place in the field of in this field. Thanks a lot, Mr.
Thank
Venkatji.
you. Thank you.
Thank you.
Thank you. Thank you so much, Mr. Shaju Bhaskaran, sir. You said it very rightly that the study of space should lead into greater study of mathematics and science. That is very well said, which really puts science and mathematics in the right perspective. Thank you so much. You are a very, very senior Government of India official, and you being here gives a lot of encouragement and credibility to what we do. Thank you so much, sir. I understand what it is to going home after 7 p.m. In the Bengaluru traffic. So thank you so much for being with us here today. Uh,
Yeah.
Ladies and gentlemen, I take special privilege in welcoming Professor Venkateshwaran. Professor Venkateshwaran, a finance expert who's a teacher of finance and economics in Vivekananda College and Loyola College. More than anything, he is a prolific writer, and I need to mention that the contributions of Professor Venkateshwaran has received appreciation letters from the Prime Minister's office and from the Home Minister's office. That's Prime Minister Shri Narendra Modi ji and Shri Amit Shah ji. Sir, that brings a great a sense of honor to what you do. Thank you so much for being with us here today. And may I request you for your special address, please. Over to Professor Venkateshwar. Sir, you'll have to unmute. Professor, you'll have to unmute. Yeah, I think.
It's okay?
Yes,
Yes.
it's okay now. Yeah.
Yeah. Respected dignitaries, esteemed faculty members, students, ladies and gentlemen, I'm extremely happy and delighted to be with you all this evening. I am rather privileged to be part of this program, Explore the Space, an ISRO registered space tutor on Moon and its origins. Sri Venkatagiri's initiatives in this regard are indeed laudable and commendable. Today, I would like to say a few words on space technology, a field that is representing innovation, ambition, adventure, exploration, and the future of humanity as well. It is the age of STEM, science, technology, engineering, and mathematics. Space technology is not just about rockets, launches, or astronauts. It is the practical application of science at its highest possible level. It brings together physics, chemistry, mathematics, computer science, electronics, and even perhaps AI as well. What are the opportunities for science students is another question, which we will see later. Actually, it helps to solve the real world problems and expand the human knowledge. Organizations like ISRO have transformed scientific learning into national achievements. The success of Chandrayaan 3 proved that determination and knowledge can create history. Globally, agencies like NASA continue to push the boundaries of exploration. Space technology also has positive impacts on daily life. GPS, navigation, satellite communication, weather forecasting, disaster management, and climate monitoring all depend on space-based systems and research. It is also rapidly growing industry, offering enormous opportunities in research and development, data science, robotics, innovation, etc. For science candidates and students, learning space technology builds problem-solving skills, teamwork, creativity, and above all, self-confidence. It transforms classrooms knowledge into meaningful results. The future is exploration and expanding beyond the Earth. That is, the space technology is the pathway to the great future. Our ancient Vedas and our Sanskrit literature have abundant information on astronomy, astrology, and space science. Our forefathers could predict very well in advance the solar lunar eclipse system by scientific calculations. They could also predict the rising and closing time of sun daily well in advance. So it is in Indian culture which we should cherish and take it forward. What are the opportunities for science students in space technology or field? It is a very pertinent question. Space technology is one of the fastest growing fields in the world. It offers exciting career paths for students from all domains of science, particularly from physics, chemistry, mathematics, computer science, electronics, AI, data analytics, so on and so forth. Organizations like ISRO provide ample opportunities in satellite development, space research, mission planning, and data analytics. Science students can work in areas such as rocket propulsion, satellite communication, weather forecasting, AI, robotics, and space data science. Even private companies and space agencies like ISRO, NASA are creating avenues for new roles in research, innovation, and advanced technology. In fact, for the science students, it will be very easy for them to understand and assimilate the space science. It really helps in disaster management, climate monitoring, prediction, particularly for agriculture-related information, ocean resourcefulness, research and communication systems on Earth. It enables us to equip ourselves to declare and go in advance and solve real-world challenges and issues. With strong fundamentals, curiosity, continuous learning, science students can really build rewarding careers in this dynamic field. Opportunities are plenty, vast, and it is for the students to take advantage of this area and contribute for themselves and upskill themselves, not only for themselves and for the country as a whole. In fact, I would ask a few questions for you to ponder over. Who is called the father of modern astronomy? Anybody can tell me who is called the father of earlier astronomy, and who is called the father of space? These three questions you must find out the answer, and it is very easy, and you can see their biography. It is very amazing. Actually, when I have gone through the material, I found out one Copernicus Nicholas was a great thinker and a scientific inventor. He was in 1473 from Poland. He has created a new theory, which was considered a revolutionary theory, far from the laid down theory. He suggested that theory called, which is the sun and not the earth at the center of the universe, in his book before his death in 1543. That was a very revolutionary finding, which was resisted by the ethnic researchers, but subsequently accepted, fundamentally changing the astronomy per se and science. He challenged the already held Ptolemaic system, geocentric model, and then laid groundwork for modern astronomy for showing Earth and planets revolve around the sun. So he was the first one to say that sun is constant, Earth moves, Earth and other satellites move around them. But earlier it was thought Earth was considered to be in focus. Similarly, Galileo and Kepler, they also contributed huge research findings in the area of space technology. It is highly dynamic. It is very interesting. It is inquisitive. Students should go into this field, and they have a great future. I wish all the students and researchers to take the space research to the next level and bestow their knowledge, wisdom, and experience to the next generation, so that the next generation is able to enjoy the fruits of such research findings. Thank you for the opportunity. I am indeed very happy to be a part of this. Thank you all. Jai Hind.
Thank you. Thank you very much, Professor Venkateshwaran, sir. It was very nice of you to touch the ancient text Vedas and also about Copernicus and Ptolemy. Thank you very much. Now, ladies and gentlemen, may I now invite the much awaited speaker, the keynote speaker of the day, Dr. Jaideep Mukherjee. A few words about Dr. Jaideep. Dr. Jaideep Mukherjee is the director of the NASA Florida Space Grant Consortium, a role where he oversees a network of 17 Florida universities and colleges to expand the state's space industry through STEM education and research. Based in Orlando at the University of Central Florida, He leads initiatives that provide grants, scholarships, and fellowships, supporting students in hands-on projects ranging from CubeSat launches to International Space Station experiments. Academically, he holds a PhD in astronomy from the University of Florida and has previously served as the director of the Florida Space Institute. Dr. Mukherjee is a recognized advocate for space science outreach, having received the NASA Group Achievement Award and the National Eminence Award for his commitment to engaging students in technology and exploration. His personal research interests focus on closed binary stars, emphasizing the synthesis of observable quantities and mass transfer in interacting binary systems. Thank you so much, Jaydeep, again for having agreed to be with us today. Now over to Dr. Jaydeep, sir.
Thank you very much for the introduction. I know a lot of the participants are missing the Indian-Netherlands match. Me too. We didn't start very well. But anyhow, this is a good time to talk about the moon because, every country wants to go to the moon for various reasons. But my talk will be more on the moon itself, how it was formed, the search for water on the moon, because if you want to have settlements on the moon, we need water, and we can't carry water from the earth. And then I'll talk about some issues with the moon dust called the regolith, which is going to cause problems to a lot of astronauts who are going to land on the moon. So I'm going to give you some ideas on the problems and some of the research being done over here to mitigate these problems. So I'm coming from a small town across Kennedy Space Center. If you look at the map, the picture of Florida behind me, on the right coast, somewhere in the middle is where we have Kennedy Space Center. And I'm just sitting right across it. And behind me, you just see my picture, but 20 miles behind me is the NASA rocket Artemis 2, which will launch in a few days, carrying 4 astronauts to the moon. They won't land on the moon. They're going to go around the moon and come back. It's just a test of the spacecraft. But tomorrow there's going to be what is called a wet dress rehearsal, where they start fueling the tanks and they look for leaks. And if there's a leak, we'll stop it and go back and figure out. So it's a good time to talk about the moon because India wants to go to the moon. China, Russia, the US, and so on. And I'll tell you again why everyone wants to go to the moon, and why it has become such an exciting place. So let me just share my screen. I do this minutes sometimes, but I always forget how to do it. Oh, there you go. Do you see my screen?
Yes, please. We are able to see your screen.
Full screen. Okay. Sorry. Go ahead.
Yeah. Now it's full screen. Yeah.
Okay. And I'll gladly answer questions in the end. I have time today, so I'm not in a hurry. So if you have some questions, either you can put it in the chat or just ask me later on. So I just wanted to give you an introduction on the moon, and talk about its origins, evolution, and exploration. So it's basically science and engineering and the way to move forward. A lot of you, I think, are from engineering colleges. Usually when I talk about this topic, I talk about the moon and the Artemis mission to the moon. But this time I thought I'll talk more about the moon because there's so many issues that we are going to have, and people have started addressing it. And I have an institute out here who is doing a lot of work on mitigation, the problems when rockets land on the moon, and the problems with the lunar soil called regolith. So engineering plays a big part, but in any mission, whether it's in India or whether it's in China or the US, it's all to answer a scientific question. In the case of the moon, we want to go and find water on the moon. But to go there and to make measurements, we need the engineers. So in the real world, it is how engineers and scientists talk to each other. And if you cannot do that, your mission is a failure. So again, it doesn't matter where you are. You are expected to figure out how to work together. So I always tell my students, or any student, is to start working in groups right from word go. It does not have to be a very big technological project, but the idea is that you guys will talk to each other, with different cultural backgrounds, different languages, and figure out how to solve problems. And the main thing I want to learn is how to respect someone's opinion, even if it is totally different than yours. So I urge everyone to work on projects. It doesn't have to be a fancy project, but I'll tell you, it'll give you so much confidence as you go forward and join the real workforce. So, why do we want to study the moon? Hold on one second. Okay. So we want to study the moon because the moon gives you an indication of the early solar system. See, so the moon has no atmosphere. The moon has no weather. There are no plate tectonics. So the features on the moon are kind of the same as it was 2 or 3 billion years ago. So you want to study the moon because it gives you an idea of what the early solar system was. That's one reason we want to study the moon. So it's a stepping stone to Mars. Again, everyone wants to go to Mars because it has a thin atmosphere, it has some gravity. We think there is, permafrost, there might be water beneath the surface. But the problem is that if you want to go to Mars, in a minimum, it takes minimum 6 months, but that only after every 2 years. So it's a 6-month journey at least to go to Mars. To go to the moon, it's a day or two, and it could be faster. So if something happens on Mars to the astronauts, it will be very difficult to send rescue missions because it takes a long time to go there. But on the moon, you can send them in minutes and reach the moon within a few hours if need be. So we want to study a technology on the moon first before we go to Mars. Now, I think you might have seen a statement made by Elon Musk. Elon Musk has been saying all these years that he wants to go to Mars. He wants to go to Mars, which he will eventually do. But a couple of days ago, he said that is shelving his plans to go to Mars right now, but focus on the moon. And that makes sense because you want to figure out how your instruments can survive on the moon, how you can go to the moon quickly, how you can look after the astronauts if they fall sick on the moon, and so on. So it's a stepping stone to Mars. It's an exploration test bed. It could spur new technologies. Now, I hear this a lot. It says, why are we spending so much money to go to space when there are so much issues on the Earth? And it's true. There are a lot of issues on the Earth, but we cannot forget everything because the only way that we can survive as a species is to explore, use our imagination, and always think forward. And believe me, space takes a very small part of the budget. Doesn't matter which country you're in. In India, it's a very small part of the budget. In the US, for every dollar that someone pays in taxes, half of 1 cent. 1 cent is like 1 paisa. So half of 1 cent is used for NASA. It is not a lot of money that's being used in space technology. The movies that we make in India and in the US sometimes cost more than NASA missions. So we don't spend a lot of money, but the upside is that by doing all these things, we come up with new technologies. Half the technologies that you're using now is because of space technology, whether it's your phones, your GPS, even breast cancer software has come from software to look at images of faint objects in a galaxy. Velcro, even diapers and so on. I can go on and talk about hundreds of things that have resulted as new from space technology. So it's an exploration test bed, and it will. I don't say it should. It could spur. It does spur new technologies. And here's my favorite thing, and here's where you come in, and that's why I think I'm so glad to see so many of the students over here. It has the potential to inspire a generation of engineers and scientists. So I hope that, some of you, everyone doesn't have to be a scientist, everyone doesn't have to be an engineer, but space is big. And believe me, when you talk about space, it's no longer just science and engineering. It could be architecture, it is medicine, it is law, civil engineering. You have to build structures on the moon. Um, you need to figure out how to give an injection on the moon. What kind of medicines can be provided on the moon, and so on. So it's not just science. It's not just engineering. And now we've gone to medicine, biology, chemistry, and so on. If you want to be a part of the space program, you have so many opportunities. So this gives you an idea of the moon, and it's a natural satellite; it's not artificial. There have been 24 human visitors on the moon. 12 have landed. Here, what you see are some of the landing sites of the Apollo missions. And if you notice, most of them are near the equator, none of them near the North and South Pole. It's very difficult to land on near the North Pole or the South Pole for a variety of reasons. Here's the landing on the moon. It shows you successful moon lander and impactor missions. Impactor means a small satellite has gone and hit the moon um, deliberately for experiments. So if you look at the US, it has 15 landings on the moon, 11 were robotic landings, and 4 were impactors. USSR had 8, China has 3, and India has 2. One lander and one impactor. This is very impressive. Look at all the nations in the world. There are only 4 nations which have landed on the moon, and India is one of them. And India's space agency is pretty young. So here are some of the moon landings of different countries. Again, as you see, most of them are near the equator. Some of the significant events is Luna 9, and that's the first spacecraft to land on the moon, and that was the Soviet Union spacecraft right over here. Then another main mission was Apollo 11, which landed 2 astronauts on the moon, and that's over here. Another mission is Chang'e 4. The Chinese are doing great, believe me, on lunar missions and space stations. They are very far ahead, almost in par of the US, but far ahead of every other country. And Chang'e was the first spacecraft which landed on the what we call the far side of the moon. The moon is such that its rotation rate and revolution is almost the same. So we almost always see one side of the moon. We don't see the other side. And there's a misconception in literature and in science fiction. They call it the dark side of the moon. And that's not the right terminology. It is not dark. We just don't see it because we're only seeing one side of the moon because of its same rotation revolution period. But it has sunlight and it's not dark at all. So Chang'e 4, I don't know how you pronounce it, Change 4, was the first one to land on the far side of the moon. And then finally, here you have India is the only country which have landed near the south pole of the moon. The only country so far. And I tell you, it is not an easy place to land. When they land near the equator, if you notice most of the landings, they are what is called this. You see these dark patches, and most of them have landed there. And these dark patches are actually solidified lava. And I'll talk to you more quickly about that. But they have solidified and it's smoother compared to the other areas where you have a lot of craters. So they try to land close to these smooth areas. Hopefully now with a lot of countries trying to go to the south pole of the moon, I'll tell you why they all want to go to the south pole soon. Again, here's another example of landing attempts. And if you notice that after the 70s, for about 30, 40 years, there have been no missions to the moon. And most of it's budget, and people didn't think it was an important thing. There were other issues to worry about. But now, with advances in robotics, with artificial intelligence, with great software, a number of countries have started to go to the moon. And this is the folks who have traveled to the moon. This said 12 have landed on the moon, and less of them have actually gone around the moon. And if you look at Apollo 13 over here, the three astronauts were supposed to, two of them were supposed to land on the moon, but there was an issue as it was going to the moon and they had to come back. They survived the trip. But otherwise, it was a crew of three. Two landed on the moon and one was orbiting the moon. So that's why usually two on the moon's surface and one orbiting. Here are some of the moons of in our solar system. So this the diagram I show you out here shows the Earth, and in comparison to the size of the Earth on the picture are the other sizes of the moon. So they are to scale. So if you look at the Earth's moon, it's very kind of large compared to the Earth itself. It's not larger than the Earth, but if you look at the Earth's moon and you look at the other moons in a solar system, apart from 3 or 4 moons, the Earth's moon is the largest. Ganymede and Callisto and 3 others are larger, but most of them are smaller moons. But in relation to the size of the Earth, the moon is pretty large. Now, facts. So here's my pet peeve. I don't want you to memorize everything. There's no need to memorize. It doesn't help you at all. You forget things. You try to get relations. Some things you need to memorize, like the speed of light, the gravitational constant. You need to memorize that. But most of the others, you try to find relations, and you remember that more than anything else. When I was growing up, in Mumbai, that's where I got my bachelor's and master's. We used to memorize to answer our exam questions. It's not a good way to learn. So don't need to memorize, try to understand, and will remember it for the rest of your life. Saying that, I still have some numbers in here, just in case for some folks who like numbers. I give you the mass of the Earth, the mass of the moon, the diameter, the density. Look at the density of the moon, and I want you to remember that because it'll give you, it'll explain how the moon was formed. So the mean density of the moon is about 3 grams per centimeter, a lot less than the Earth. Look at the surface temperature. It ranges from minus 200 degrees to plus 100 degrees centigrade. And the reason is because it has no atmosphere. Because it has no atmosphere, it cannot retain the heat. The heat dissipates in the night when the sun sets, and it gets very cold. And then when the sun rises again, it gets very, very hot. Gravity is about 1.17 out of the Earth. So you can jump. If you go to the moon, you try to jump, you'll jump a lot higher, but 6 times higher than you can do on the Earth. So that's because it has less gravity. And then you have these some indication of the temperature range, the air pressure, and so on. Again, just to give you an idea on what the numbers are. No one expects you to remember most of the numbers. And here's the way I try to show is a relation. So diameter of the Earth is so much, 12,000 kilometers. Diameter of the moon is 3,000 kilometers. I look at the relation. I would say, the moon is about 27% smaller than the Earth, the diameter of the moon. Surface area. Who remembers these numbers? But I can remember like 7% of the surface area of the moon is 7% that of the Earth. I can remember that. Again, the volume is 2% of the Earth. The mass of the moon is about 1% of the Earth. The mean density is about 0.6% of the Earth. Gravitational acceleration is about 0.16 of the Earth. And this is an important thing, for future exploration. the gravitational acceleration on the Earth is 9.8 meters per second square, which means that if you want to leave the Earth's orbit, a rocket speed has to be more than that, which means more fuel. More fuel makes a rocket heavier. But if you are launching rockets on the moon, you won't need that much fuel because look at the acceleration is 1.6 meters per second square. So we don't need to have tremendous speed to escape the gravity of the moon and then go to other planets. So that makes it's a lot easier for us to go to the moon and then launch to other planets. That's why in the future we're going to have settlements on the moon, we're going to have launch pads on the moon, and so on. So the escape velocity, that's the most important thing, is 11 kilometers per second on the moon and on the Earth, and 2 kilometers per second on the moon. So a rocket has to have more than 11.19 kilometers per second speed on the Earth, velocity actually, to escape the Earth's gravity, while on the moon it's only 2.3 kilometers per second. It's not much. To give you an idea of the moon's composition, so it has a core. We think it has a solid core and a molten iron core, and then we have a crust, which is very similar to the Earth. And so we look at the crust on the top over here. That's a small area where it's solidified, and it's mostly made of basalt, so that's why it's lighter in color. But as I'll show you in the next few slides, we also have what is called lava flows. These are called marias. We used to call it seas because we thought there were water, there was oceans on the moon in the past. If you go out and look at the moon and look up in the sky, you will see these dark patches in the moon, and they're nothing but solidified lava flows which seeped out from inside the moon as it was bombarded by meteorites and asteroids. So that's kind of the composition of the moon. 60 kilometers is the crust. And then you have a solid, what's called a lithosphere, which is like the Earth's mantle. Earth's mantle is just beyond the crust. And then you have the core, an inner core and an outer core. And these are the surface features of the moon. And remember I told you those dark patches, which are called marias or seas. It's a younger surface because it was formed later when as the moon was cooling, it formed the crust. But the moon has no atmosphere, so it was heavily bombarded, and you can see all the craters. But some of the objects hitting the moon were so large that it cracked the surface. Lava seeped out, solidified. Lava is actually, the material is dark in color, and so we see these dark patches. So you have the highlands, which is the cratered surface, and we call the maria, which is the less cratered and darker surfaces. And there are a lot of other features on the moon. You have something called a ray crater. A ray crater is actually when you had an object hitting the moon, it ejected matter out. You can try this on the Earth also. You go outside, if there's mud, and throw a small rock on the mud, you'll find matter spewing out in different directions. So in the same case over here, when the moon was young and was just solidifying, a big object came and hit, formed the crater, but matter went out and formed this rays. We call them ray craters. And then you have marias. There's something called riles out here, as you see. What is it? Is nothing. It's just lava tubes that where lava flowed in the past. They're solidified. Why are these important to us in the future? Is that if you want to have a settlement on the lunar surface, it's great, you can do it. But the moon has no atmosphere, so it's bombarded by radiation. So unless the structure that you built shields you from the radiation, you'll die very soon. You have to have a suit to breathe, also to protect from the radiation. But if you can have a settlement inside these lava tubes, then it's a possibility that the lava tube itself can shield you from the radiation. So people are looking into it, in the future, 20, 30 years from now. Can we go and have settlements in the lava tubes instead of on the surface of the moon? And I said the rocks of the moon are mostly basalt. It's like a granite-like rock, and it's lighter in color. Um, and also silicates like iron and oxygen, and they make up over 96% of the Earth's surface. Same thing on the moon. You have a lot of silicates. So this animation will show you the difference between why the crust is lighter in color, why is the Maria darker in color. So just watch this animation. Just show you the moon going around the earth, and the earth is also rotating. But look, the lighter elements on the top, they float to the top because they're lighter, like silicates. The heavy elements, iron, they seep down, so it's dark because iron is dark. So when the moon was forming, when it was bombarded by meteorites, lava seeped out, and then it solidified and formed the Marias. So if you take a rock from the cratered side, it's lighter in color, and if you take a rock from the Maria, it's darker in color. I don't know whether you can see this. I'm going to talk to you about this later, but
Yeah. Yes, Jay.
can you see this? Can you see
Yeah,
this?
we are able to see a bottle.
Yeah. So what I'm showing you is artificial soil that we have manufactured here in Orlando, and
Okay.
this represents the material near the Maria. That's why it's dark in color. And if
Okay.
I show you this bottle, you'll
Yeah.
see it's lighter in color because
Okay.
this mimics the soil in the craters and is mostly made of silicate. That's what's lighter in color. And I'll talk to you
Okay.
more about this later on. But they are different in colors just because of the materials. And the lighter materials float to the top, and the heavier materials like iron, they go below.
Come to the bottom.
The other important thing that is going to cause a major problem, major problem, is what is called the regolith. Regolith is just another term for the soil. So on the left, you will see some of the regolith that has been collected during the Apollo 17, the last mission to go to the moon. But it's a layer of loose deposits covering solid rock on the moon. And it occurs as a mixture of powdery dust and broken rock, the regolith of the soil. And this regolith is formed by the impact of meteorites on the moon's surface. Again, the moon has no atmosphere, so it's constantly being bombarded. And as it does that, it breaks up and it forms this lunar regolith. And in the end of this talk, I'll tell you how much of a problem that's going to cause us, this lunar regolith. So it typically refers to the small fraction of the lunar regolith. We call it the soil. But for our purpose, and if I say soil, if I say regolith, let's assume it's the same thing. We're not going deep into what the soil and regolith is. And the building blocks of the lunar regolith, they are like silicon, aluminum, titanium, iron. They're all which make up this the regolith of the soil that you see on the surface of the moon. It is actually finer than sand. So the bottle that I showed you, these particles here are actually finer than sand. So you don't want to actually inhale that. And to show you, this is a spacesuit worn by James Irwin on the moon, Apollo 15. Spacesuits are actually white in color. The reason they're white in color is because they reflect sunlight away. But look at this. It has become gray in color. And the reason is all the regolith, as they landed on the moon and they walked on the moon, all the regolith came and clung to the spacesuit, making it dark in color. So you have regolith flying everywhere. Not just like that because there's no wind on the moon, but if you're walking on the moon, if you're a rover on the moon, or if rockets land, then yes, regolith causes the problem. So now I'm going to talk to you quickly about the formation of the moon. And here I want to show you how science progresses. One thing to remember, anything I say or anything a scientist say is not the final word on that. That can change, and that's the beauty of science. We are willing to learn from our mistakes. We are willing to change our hypothesis so that it matches the facts that we see. So I'm not going to go into details, but any theory or any hypothesis to explain the existence of the moon has to explain three features. One of them, why is the moon's density lower than the Earth? So we know the moon's density is lower than the Earth. So any explanation we come up for the formation of the moon has to show why the moon's density is lower than the Earth. Second thing is the moon rocks contains very little water. So which means that the moon was heated a lot relative to the Earth. In the Earth, apart from having sea, oceans and seas, the rocks also had water molecules. So for some reason, the moon was heated a lot. So the moon's lunar surface was baked a lot relative to the Earth. And finally, remember this one, something on isotopes. So the relative abundance of oxygen isotopes on the Earth and the moon are the same, which means that the Earth and moon formed the same distance from the sun. It's not that the Earth was formed in one place, the moon was formed elsewhere. Because if that was the case, then the abundance of oxygen isotopes would have been different. So what is an isotope? Isotope is nothing but an element which has the same number of protons in a nucleus, but different number of neutrons. And in the case of oxygen, we have three naturally occurring stable isotopes. Again, same number of protons, but different number of neutrons. And the relative abundance of the same is the same on the Earth as on the moon. So remember this. Remember these three things as I try and show you the different ways the moon formed. So the first one is called a captured hypothesis. And what that means is that the moon was formed somewhere very far away from the Earth. It somehow came close to the Earth and the Earth captured it. Now these ideas, hypotheses were a long time ago when we didn't have the technology, the computers. So I showed you, the moon is forming somewhere else, but coming close to the Earth. But we know because of the abundance of the relative abundance of oxygen isotopes are the same on the Earth and on the moon. It means the moon could not have formed far away from the Earth. So we had to reject that hypothesis. We came to the next hypothesis, and it's called fast rotation. And they thought that in the past, the Earth rotated so fast that a part of it came out and formed the moon. And at that time, they thought that the Pacific Ocean was the area where the moon was flung out, or part of the Earth was flung out to form the moon. But again, if you look at the analysis of the angular momentum and the energy that we need to do this, it was not possible. So we had to get rid of that hypothesis of fast rotation. Then we came up with an idea called co-accretion, which means as the solar system was forming, the Earth and other planets were formed from all small particles near it. And this idea said that the Earth and the Moon was formed from the same area where you have this small dust particles and smaller particles came together to form the Moon and the Earth. They all came from the same area. And that could explain the relative same abundance of isotope. But if that was the case, if they all formed from the same material, then the density should have been the same. The moon's density should not have been different than the Earth if they were all formed from the same material around the sun. So we had to ignore that hypothesis. Finally, the prevailing idea right now, that could change, but which answers most of our observations, is that an object very close to the size of Mars, when the solar system was forming, came and hit the Earth at a glancing angle and ejected matter from the mantle, not from deep inside, but from the mantle, and it cooled down to form the moon. But as the moon was forming, the Earth was very young, and the heat from the Earth baked the moon more, so there was no water molecules on the moon. That's explains one of the reasons. Second thing is its density is less because the Earth's crust and mantle is lighter and not as dense as the core of the Earth. So if the material was stripped from the mantle, then the density of the material was less than that of the center of the Earth. So the density of the moon is less than the Earth, and that explains those three observations that we had to explain. So we now think that the collision is the best way to explain the formation of the moon. But if we get better ideas, better data, we will change our hypothesis and our ideas. And I think that's the beauty of science. So this is just a video which just shows you how they evolved over millions and millions of years. Just watch it. Um, there's a lot of artistic license, and there is sound in this video. Of course, in space there is no sound. Sound cannot travel in space. So ignore those artistic uh, differences. But this is an animation of how the moon was forming. It was mostly molten lava slowly solidifying to form the moon. And then again, ignore the sound. Okay, this is just cinematic effects. But you have these different objects coming and hitting the moon to form different craters. And you look at the top right, it says it's the time period 4 billion years ago. Again, this is just an animation, but look how those lava seeped out to form the mareas and then they solidified. So this is still molten lava which seeped out because of the cracks on the surface. And then they slowly cool down to form the mareas that you can also see with the naked eye. You go out and look at the moon, look up at the moon. So there you go. That's where we are kind of right now, the dark patches and then the heavily cratered areas. And then after that, we had some more catering, some more impacts, and that formed some of the craters on the mareas. The intermediate bombing of the moon. It was heavy bombardment in the beginning. But as the materials all formed different objects, there were fewer materials particles to come and hit the moon. This is about 1 billion years ago. So that's what the moon looks like now. And this is a real image of the moon. So that just gives you a lunar reconnaissance orbiter is a spacecraft orbiting the moon. And it took images and data to give us this. So now I'm going to switch topics a bit to talk about search for water on the moon. Why it matters, what we know, and how we search for it. Again, I'll tell you why we're doing that. So why do we look for water on the moon? Okay, to support future human missions or future mankind missions. And that's because if you want to have settlements on the moon, we need water. We need water to breathe, we need water to drink. We can take water and create oxygen, and we can use that to for us to breathe. Water can be converted to fuel and oxygen. We can use it to come back to the earth apart from breathing. And also it gives an idea about what the moon was in the past, which means what the solar system was in the past. But the most important reason are the first two, support future missions and use it for fuel and oxygen. That's why we're all looking for water on the moon. The earlier ideas, when we got back samples from the Apollo 11, Apollo 12, 14, our technology was not good enough to detect any water molecules in the rocks. And we thought that for years and years that the moon was very, very dry. No evidence of water molecules. When I talk about water on the moon, don't expect, I'm not talking about lakes or ponds. I'm talking about molecules, which you can barely see. And these molecules are in the rocks. So in the past, we thought, there was no molecules. Then In 2008, when you had better technology, we looked again at the samples, and we could detect, molecules of water in some of the lunar rocks using a new technique to detect water. So technology plays a big part in changing our understanding of anything in our environment. So then you have missions like Chandrayaan-1, that was the first one to detect water on the moon, water molecules. Then you have Cassini and Deep Impact that detected hydration on the lunar surface. Hydration meaning the surface has water molecules. The problem was, as I was explaining right at the beginning, the problem was at that time, the technology that we had, we could not detect whether the molecule was water, which means two hydrogen and one oxygen, or was it hydroxide, which is one hydrogen and one oxygen? We could not figure out the differences. So, yeah, we thought we saw these molecules, but we did not know whether it was H2O or OH. So, we could not definitely say these were water molecules. But then we have better technology, especially infrared spectroscopy, which means you bombard the moon surface with infrared, and then this water molecules absorbs a certain part of the infrared radiation. So when the infrared is reflected back, is missing some of the part of the infrared radiation because it has been absorbed by water and hydroxyl molecule. And with better radar, we can penetrate deeply on the surface. So we have a better idea that there is water molecules apart from OH on the moon. It's just good technology. So there are three types of lunar water. And I'll talk about that. Water ice in permanently shattered regions, which means that if we go to the north and south pole of the moon and you look at the craters, you look at the crater floor, we think there is water ice. And I'll tell you how there is ice and why there should be ice when there's no atmosphere on the moon. It's very hot. All the water should disappear. The second thing is, hydroxide bound in minerals. So you have different minerals, but you have this hydroxide molecules bound to the minerals. And so that's an indication that there is water, different types. And finally, from impacts, from solar wind and from meteorites, which might have some water molecules. They don't stay there for a long time. That's just called transient water from impacts. But from our point of view, from us using water on the moon, we have to look into this, what we think that there is water ice in some of the craters of the moon, the South Pole and the North Pole. And I'll tell you why it's only near the poles and not in the equator soon. But these are three different types of water. So water is in this permanently shattered regions of the moon. So if you go, this is an image of the South Pole of the moon, part of the South Pole. Now, if you look at the moon's axis of rotation, it's tilted by a few degrees, just 3 or 4 degrees, as opposed to the Earth, which is tilted by 23.5 degrees. So because the moon's axis of rotation is not tilted much, as the moon rotates and goes around the Earth and as the Earth goes around the sun, in the South Pole and in the North Pole, you have very little sunlight reaching us. In fact, the sun on the North and South Pole is just barely over the horizon for months and months and months. And if you go to the crater floor, sunlight does not reach there at all. So it's cold, but it's only near the poles, because if you have a crater in the equatorial region, sunlight reaches there everywhere. So where did these ice come from? We think it came from comets. And the comets have been bombarding different parts of the solar system. It has bombarded the moon, and comets are nothing but dirty ice. It's a lot of ice, a lot of carbon. So these have come and hit the moon, different parts of the moon. If they crash near the craters near the equator and above and below that, they all evaporated. But if they crash near the craters in the South Pole and the North Pole, then there on the crater floor, very little sunlight. In fact, no sunlight reaches it. So it's very cold. The ice did not evaporate, and it still exists. Now we don't have 100% evidence. We haven't gone there and seen its water, but we are 99.9% sure from data that it is water ice. So they think that it might take about 22% of the surface material in this crater at the South Pole called the Shackleton crater. Shackleton was an explorer which had gone to the South Pole of the Earth. So this crater is about 21 kilometers in diameter or 12 miles in diameter. And I forget how deep it is. Not very deep, but it's pretty deep. But this shows you, the second picture shows you a relief of the height. So blue means low altitude, red is high altitude. So this means almost in the crater floor, the blue areas, and the orange and red areas are the crater rim. So that gives us an idea of the slope and how deep the crater is. And at the floor of this crater is what they have seen, this water ice. The way they detected it was that, again, from infrared radiation and from radar, they found that it was kind of whitish in color, the crater floor. The only way to explain it is that it's water, it's ice. Um, Again, from our other data, also we have evidence that it's ice. So it's interesting. So not only in the Shackleton crater, on the image to your right, you will see a lot of craters have water. Now the blue, unfortunately, they've used the color blue to indicate water, but does not mean that it's water in liquid form. It's just ice that we see. Um, this is the famous Chandrayaan um, data that we have got, again by absorption of infrared light, as I said. So the blue on the north and south pole shows the signature of water and hydrogen molecules. They are actually absorbing the infrared radiation which we bombarded. And as it reflected back, it absorbs some of the radiation. And from that, we figured out there is a water molecule and OH molecule on the north and south pole. And the other things are different minerals that you see. The red shows an iron-bearing mineral called proxene. So this proxene detects a certain type of infrared radiation. So we can figure out that there's almost no water molecule on the near the equator and above and below that, but there's a lot of proxene, and so on. Now, this is, there is sound, there is an explanation. And the reason I've kept it because it really explains the detection of water with animation. So I did not remove the sound. I'm not going to talk. Listen to the sound narration of this video. So this is just explaining to you how we use different detection methods to detect water. It may not be direct detection of water. In this case, they know that if there's a hydroxide or a water molecule, it is hydrogen. And these neutrinos can actually interact with this hydrogen. And that gives an indication by studying that the presence of hydrogen atoms on the moon. It's an indirect way. Another way that we can have hydroxide or water molecules on the lunar surface is by the bombarding of the moon by what is called the solar wind. The sun is always emitting the stream of very high energetic particles, which is nothing but charged hydrogen ions. It's just a hydrogen atom without the electron around it. This is like a proton. So they're completely bombarded by this solar wind. Now, I told you that the rocks of the moon have a lot of silicates and oxygen bound to these rocks. About 40 to 60% of the rocks have oxygen molecules. So what happens is this hydrogen um, coming at a very high speed, hydrogen proton, hydrogen ion, they come and hit some of these molecules which have oxygen, and they eject the oxygen atom from the molecule. So now you have free-flowing oxygen atoms, free-flowing hydrogen. They can combine either to form hydroxide or H2O. So this is one way that we can have water in the moon. Now, that is not enough, anyway enough water to do anything. It's just a way to show that there could be water molecules, but we need like billions and billions and billions of this water molecules to actually use it as water itself. But just to let you know that there are various ways that water molecules can be found on the moon. Again, I don't want to go into this chart, but this shows you different ways that water can be on the moon. Um, um, there was volcanoes in the past, not now, and they release water and oxygen. Comets and asteroids. I told you comets will have hit the moon and left water, especially in the South Pole, from solar wind and so on. The various ways that you can get water on the moon. And I said water from comets. Comets are nothing but dirty ice and carbon, a lot of ice, and when they bombard the moon, they leave behind the ice. And that's what you're seeing in the South Pole of the moon. So I'm just showing you this because this could be a bone of contention in the future. So I told you that the craters, the moon's axis of rotation is just about 3 or 4 degrees, which means that the sun is just above the horizon. Now, if you want to have a settlement near the South Pole, we need energy. And where does most of the energy come from? On the Earth, with spacecraft. It's from sunlight. We can convert that to electricity. But if you're on the floor of the crater of a moon, or even near the crater rim, very little sunlight reaches there. So where are you going to get energy? You cannot carry nuclear material to the moon, a lot of it. So we have to figure out a way to get the solar energy. So what they have done is they've looked at areas around these in the South Pole where there's a little elevation, like a small peak, from where you have always have sunlight and you also have a direct line of view to the earth for communication. So these are called the peaks of eternal light, and there are a number of them which have been identified. So now look what happens. Any country that goes to the moon would like to land near these peaks of eternal light, right? Because they need sunlight. So, we have to figure out now laws which can protect any country that is landing near this. We don't want a country to land near a peak of eternal light and say, that's mine. No one else can come. Unfortunately, right now, we don't have any laws to talk about all these things on the moon. So space law is a very important topic these days. But I just wanted to point this out to you because it is going to be a point of contention among countries in the future. Who's going to land where and who owns what and so on. Venkatagiri, how much more time do I have?
Deep, we are good with another 15 minutes.
Okay, I'll be done with that. Okay. So now I talked about the moon. I talked about search for water on the moon. Now let me talk to you about moon dust. And I'm talking about that because a lot of research is being done at Kennedy Space Center and at the University of Central Florida. Um, we have a lab called the Excellent Lab, and I'll show you pictures. That's where we manufacture these simulated artificial lunar and lunar soil. But I'll tell you what are the problems with the lunar dust. Here is a statement by the Apollo 17 commander, Gene Cerner. He says, I think, this is how we know I'm talking about more than 50 years ago. I think dust is probably one of the greatest inhibitors to a nominal operation on the moon. I think we can overcome other physiological or physical or mechanical problems except dust. And this was, as I said, 40, 50 years ago. He understood that's going to be a problem. Look at this another astronaut's David Scott's spacesuit. It's filled with this dust. This dust or regolith is smaller than a sand particle. It's very, it has a lot of jagged edges, and it can actually if it's not careful, it can tear the soil, tear the fabric, and so on. Of course, it can cause other problems too. So, one thing is that it darkens the surface. So, if you have a lot of dust, like you saw the picture of the spacesuit, we want it to be white so it can reflect sunlight. But if it gets dark, there were problem in transferring the heat, and that caused problems. So, it darkens the surface. It's the abrasive nature of the particles. They're so ragged edges that it can rub and wear down surfaces through friction. So it can cause problems with sensors, with small spacecrafts, and so on, if it is not shielded properly. Um, the negative effect on coatings used in caskets, um, that can cause a problem with this dust. They can affect the coatings that we have on lenses, solar panels, as well as wires. Yes, if by chance you breathe some of this, it can cause a lot of problems with the nervous system, with the lungs, and so on. And finally, something called arcing. The moon is charged electrically because it has no atmosphere, and that can cause problems with spacesuits and instruments and sensors. So the number of issues that we have, I've not talked about a lot more that we have identified. These are some of the issues that in general people know, but I'll show you some more. Some of these experiments are not yet um, sent out to the general public. I'm giving a first peek of it. Before I do that, I want to show you a video, an actual video of the descent of Apollo 15 as it lands on the moon. And as you can see the regolith being flung apart. Just watch this. So they took the data, the video from Apollo 15, and then took the data from lunar reconnaissance orbiter to form a better view of the surface. So on the left is Apollo 15 video, on the right is the same area seen by LRO. About to land. Now watch. What's on the left hand side? Look at all these dust particles being ejected out. Now you can barely see the surface. Did you hear the last thing that he said? Bang. Because he didn't expect, because they couldn't see the surface at all. And they didn't expect such a rough landing. And actually, as it landed very close to a crater, and the lunar module was tilted by about 11 degrees. A little more than that, they were lost communication with the Earth. Again, they could not see where they were landing. So here you go. You look at the top image, they show you three different views as you come closer and closer to the surface. This picture was taken by other spacecraft, and it shows the lunar module tilted backward into a crater. And that was not visible when they were landing. If you remember Apollo 11, as Armstrong was about to land, it was all computerized, and they were supposed to land in a certain area, and he found out that the area was full of rocks. So actually, he took control over the spacecraft, the module, and they flew beyond it and landed elsewhere. Here, as they were landing, they couldn't see this crater very well. Luckily, they didn't land too much near the edge of the crater, so it was not tilted a lot. So issues like this will happen as we have more rockets landing. As the larger rockets landing, more dust will be emitted out. So here's a briefing by 300 feet. We picked up a tremendous amount of dust, much more than I expected. The dust went as far as I could see in all directions and completely obliterated craters and anything else. I knew there was the ground underneath the dust. I couldn't say what was underneath me. I was just going to have to bite the bullet and land because I couldn't tell whether there was a crater down there or not. That's scary. And when you're landing somewhere, you don't know what's happening. We don't want that with other landers now as we land on the moon. And here's another thing: as a rocket lands on the moon, is actually ejecting fuel out, and it forms a plume to slow down. On the Earth, because of gravity on the left, the plume is actually very narrow. On Mars, it's a bit different. But on the moon, because the gravity is 1/6, the plume is not narrow, but spread apart. And because it's spread apart, you can eject more matter away. So when you're landing, a rocket lands on the moon and it's trying to slow down, the plume from the rocket will actually be more wider on the moon, and it'll eject more of the matter out. So that's an issue. And we have seen even rocks being ejected along with this dust that is being emitted. Some of the rocks are the size of a fist, as you can see here in the yellow circle. The rocks can be blown too. So if you have something close by, if the rocks come and hit that object, it can cause problems. So imagine having, say, India landing a rocket, and then you have a Chinese rocket close by, and as the Indian rocket lands, dust is blown and rockets are blown and it hits the Chinese rocket. It'll cause problems, or any two countries. So we have to be careful about that. So what we have seen is that there is a unmanned, uncrewed spacecraft called Surveyor, which landed in Apollo 15. So what this Apollo 15 astronauts did was they went to the Surveyor, and there was this area where they cut a bit of the fabric from the spacecraft and they brought it back to the Earth to study what happened, because Apollo 15 landed very close to Surveyor 3. As Apollo 15 landed, we saw all this material being ejected. They actually sandblasted the Surveyor spacecraft a bit. So they took a part of that, on the right-hand side, you see this piece is cut. They brought it back to Earth, to Kennedy Space Center, and my colleagues looked at it to study the impact. And you can look out here on the left-hand side. Some areas are whitened more than the others, and that's where you have this material from the landing of Apollo 15 hitting the Surveyor 3 surface and causing this different parts to be different. It's like sandblasting. So we know it can cause a problem, and we know this because we brought the material back to the Earth and studied it. And if we did some computer simulations. When I say we, not me, engineers and scientists did that, and they found out that as the material was ejected by Apollo 15 as it landed, luckily most of it went over the Surveyor spacecraft. If it had hit the spacecraft directly, it would have caused more damage. Again, these are indications that we have to worry about things if they have more than one spacecraft landing close by. So luckily, most of the ejector flew over the Surveyor. But even what did hit caused considerable damage. So how do we get rid of this plume effects? So one of them is actually building lunar landing pads. So what happens is if you have a landing pad, so you have a rim around the landing area, it can block the ejector from the rocket itself. So you can have different lunar landing pads. And here at the Kennedy Space Center, they are working on ways to build this landing pads. So just finally, I'm going to tell you why we are doing all this, because we have a lab here called the Accelerate Lab and a subsidiary called the Space Research Technologies. And what we do is we actually build, manufacture the lunar regolith. So we know the constituents of the materials of the rocks near the crater, near the Maria. Most of the rocks you can find on the Earth, so we go and find those rocks. There's certain types of materials. We grind them to the right size, mix them properly, and we come up with this. So these things that I'm showing you, they actually mimics the moon's surface. We have done the same thing with Mars. But we have also created a big bin, as you can see, filled with this material so we can do testing. When rovers land on the moon, they're going to land on this very powdery surface. If you do not figure out a way for rovers to walk on the moon, it's tough. And I have been having projects where students for the last 4 or 5 years have been building rovers with correct wheels and everything, so they can test it on this surface. And in fact, in my website, I have the files to 3D print the rover itself. And even the software is free of charge. Anyone can download 3D print the rover, come up with their own plans to come up with a wheel or an arm, and then test it. You can test it on sand, but we are testing it on what is called the regolith bin. And here's another picture of the regolith bin. Again, because it's so abrasive, you have to wear suits to be in that room where you have the bin. Here we do some testing to see what will happen if we land on the moon. So they do build a small replica of a rocket and let it land on this regolith bin, and they see how the matter is scattered. And also, if you look, we have lights which are low on the horizon to mimic the sunlight on the moon. That's why we see these long shadows, because the lights are right near the surface. So we are testing everything in this sandbox. Here's some more pictures of the testing is done. On the top right, you'll see the kind of a replica of a rocket landing. So it's just a plume hitting the surface and then ejecting the matter out. There's a lot more I don't have time to talk about, but here at this place, it's the world's leading producer of high fidelity regolith simulants. We simulate the moon, Mars, and asteroids. And these are some of the simulants that they have created: lunar and Martian and asteroids. And these are different things. In fact, any one of you can buy. You can go and go to the website and you can order and they'll ship it to you. So they have come up with some guidelines to protect lunar sites. One thing is that tangentially landing trajectories, so that the plume planes are pointed away from the heritage sites, landing behind natural terrain barriers, or create landing pads, or after landing, hop a bit so that you don't eject a lot of material at one time. So these are just dialogues going on. Nothing has been finalized. Potential scenarios of future conflict, when I say a state, it could be any country, anything. They place a sensitive telescope at the center of a resource-rich zone as a tactic to force other nations away. That's possible. They put outposts on all of the best peaks of eternal light, and they claim it should be theirs. We can't allow that. A state claims another state damaged its hardware by landing at a location far away. Instruments on an orbiting spacecraft are ruined by sandblasting by a lunar lander. Think that this got potential scenarios, and as more countries go to the moon, we have to worry about that. And then finally, there's something called the Artemis Accords that has been NASA, in coordination with the US Department of State, came up with this set of kind of rules. These are not legal rules, but just in some understanding. It started with seven other countries, but it's understanding that we follow certain rules and we follow best practices and not cause problems, with landing and so on. So right now, as of January 26, 61 countries have signed, including India. So we need to figure these things out to have a safe exploration of the moon. So I'm going to stop here because I think I've taken enough of your time. Thank you for listening, and I have time to answer questions.
Thank you. Thank you so much, Jaydeep. That's one another fabulous presentation from you. I am at loss of words to tell how lucky and fortunate all of us are. Jaydeep sir, we have some questions at the chat box. Would you like to have a look?
Why don't you just tell me what they are?
Yeah. The first one is, are there any other different elements found in the soil of the moon?
Different than what? So yeah, they have found a number of minerals that we know also exists on the Earth. Yeah, so they have detected a number of minerals. Now I think what the writer is trying to point to is that there is this not idea, but we know that if you go to asteroids, there are minerals in some asteroids which are so rare that if we can bring these minerals back to the Earth, a diamond will be cheap like hell. So I don't know whether the writer was the questioner was trying to go to that, but on the moon, yes, we have detected a lot of different types of minerals, a lot, but most of them are found on the Earth. But on asteroids, we know there are minerals which can help a lot.
The next question is, are there volcanoes in the moon? Are there evidences of early volcanoes?
No. The moon is dead geologically. Okay. But there are sometimes moon quakes, not because of plate tectonics, but because the moon is still cooling. And as it cools, sometimes you have seismic waves going. But it got nothing to do with plate tectonics, which causes earthquakes. And all volcanoes are just cool down. So it's geologically not active at all.
Okay.
That's a good question.
The next question is, what are the holes on the spacesuit? We were able to find some holes, which the big, like it was like big buttons.
No, those are buttons. Those are not holes at all.
Oh, okay.
You have a hole on a spacesuit, you're dead. Because if you have a hole in a spacesuit, oxygen will come out, and the regolith will go in. So those dark things that you see are actually it was actually just some buttons or something like the patches.
The next question is, how do we manufacture regolith? How do we manufacture?
So we get this different rocks from different parts of the world where it has the minerals that we know are in the lunar rocks. So we bring these rocks and we crush them. We crush them to small particles. We figure out the actual size of the particles because we have an idea of what the lunar regolith is, and then we mix them properly. So as I said, as I show you this, and I don't think you can see it properly, but here It's
Yeah,
dark out here because we took
yes.
minerals on the earth that
Okay.
have, sorry, rocks on the earth that have those minerals that we found on the
Okay.
Maria, and
Okay.
then we use that to mix them.
Okay.
Yeah, it takes time. You have to find the rocks, you have to crush them, you have to put the right. And the reason they can do it because we have a center called the Center of Lunar and Asteroidal Surface
Okay.
Science, and the
Okay.
scientists have figured out ways to
Okay.
actually determine the
Okay.
lunar regolith materials.
Jaideep, there is an interesting question. Can't we spray water before landing to avoid pests? Before the landing,
Yeah,
can't
that's
can't we
great.
spray?
That's great. The problem is with
Okay.
any missions is
Okay.
carrying water makes a rocket very heavy. So
Okay.
you
Okay.
carrying water, that means you make a rocket heavier, which means you need more fuel, which makes the
Okay.
rocket heavier again. And that's how we cannot carry water to the moon for ourselves. We have to find water on the moon, like in the South Pole. But I like that question because that person is thinking on ways to mitigate. And I'll tell you, because I work with students, I love to get their ideas.
Okay.
99% of the ideas may not work, but students are not constrained by like engineers and scientists. They can think outside the box and they can come up with great ideas, and some of them might work. Yeah.
Okay. Thank you. Thank you, Jaideep. Jaideep, there's another question where they say, so at this point of time, the popular belief is moon is a part of Earth which was formed after the bang. Is that so?
Yes. So remember the four scenarios I
Yeah,
showed?
yeah,
The
yeah.
fourth one is the collision of a Mars-like object.
Okay.
So right now, that is the prevailing theory. We have not
Okay.
come up with any other hypothesis which can
Okay.
make this theory obsolete.
But you also said it is believed now, which means if future analysis or if future research is going to, I mean, give us some other result, then we might have to.
I won't say may, if it gives.
Okay.
If it gives some other result, we will change your ideas. Yes.
But
Yeah.
as of now, the moon is believed to be a portion of Earth which was created
Absolutely.
there.
Absolutely. There's very strong evidence, and I don't think we are going to get some other explanation. Yeah.
That's very very interesting. With that, Jaideep sir and all the distinguished guests and dear students, this webinar comes to a close. We will be requesting Jaideep sir for another session like this on Moon. My sincere thanks to Mr. Shaju Bhaskar sir, Director of the Visvesvaraya Technological Museum. Sincere thanks to Professor Venkateshwaran sir. Special thanks to Madam Kulvinder ji of the DAV Institute of Management for the great interest shown in attending. Thank you so much. We will be giving you the email ID of Jaideep sir. So if anyone is interested, Jaideep, am I right?
Yes, yes. Please email me questions and let me know that you're in this webinar.
Yeah.
Once I know that, then I will answer your emails quickly because I get too many emails. But if you say that you are in this webinar, I will definitely answer your questions. And if I don't know the answer, I'll find it for you.
Thank you. And students, we are working with the Visvesvaraya Technology Museum for a space study tour. We intend to take a space study tour to the space capital of India. Bengaluru is the space capital of India. So we plan a study tour of students, college students. That will be sometime in the month of May. Kindly look forward for that information. And I also thank Jaideep sir for having accepted to write an article in the forthcoming book on Chandrayaan missions of Bharat. That's an upcoming book by Anant Technologies, and we are very happy to be part of that. And it is a book with articles by many eminent ISRO scientists, and it is to the credit of the book that Jaideep sir has kindly agreed to write an article to be part of Chandrayaan missions of Bharat. Thank you so much, Jaideep sir, for giving your valuable time. Um, I rarely see people like you who share knowledge with such enthusiasm and such energy. And I say that people like you should be more in number so that the earth becomes a much more lovable place.
There's a request out here to share the presentations I will send you a different version of the presentation, and you can share it with anyone. And the other question was the name of the object that hit the moon, that hit the Earth to form the moon, and I think it's called Athena, but my memory is bad, so don't take my word for it. But I think it was called Athena, the object that hit the Earth to form the moon.
If there are other questions, Jaideep, can I send them to you?
Yes, please.
Thank you. Thank you again, Shaju Bhaskar sir, Professor Venkateshwaran sir. Thank you so much. With this webinar comes to a close, and our special thanks to Jaideep sir for having made this possible. Thank you, everyone. Thank you.
Bye-bye.